Okay, we'll start chapter 1, real numbers. Okay, this is one of the easiest chapters, and I don't even have to explain that much because I'm quite sure you guys already know about it. Basic convenience. So express is product of its prime factors. So you just take 5 zeros. I'm not going to do all the questions, okay? I'm just doing some of the questions because it's quite easy. And then you just do this. This is called prime factorization. And you do it only with prime numbers. That's why it's called prime, okay? So 5, 1, 0, 0, 1. You could literally do with a big prime number also if you can. Like, for example, you can directly divide by 23 also, if you can, because 23 is a prime number. Got it? A prime number of cruel like a So, excuse me, I have a sore throat. So first thing, the prime numbers. First, forget about 1 now. First prime number is 2, 3, 5, 7, 11, and then we have 17, and then 19, and then sometimes, just sometimes, 23. So itura ekta to ho jabo, one of these. Okay, these are the first few prime numbers. With this, so I think everything should be divisible. So this is obviously not divisible by 2, not by 3, because 1 plus 1 is 2. And in order for a number to be divisible by 3, when you add the digits, it should be a multiple of 3. So you can't do a 5 also. Let's try with 7. So 7 1 7, 3 in hand, so 7. Okay, we can do the 7. So 7 1 7, 3 in hand. 7 4 28, 2 in hand, 7 3 21, right? Now 4 5 6 7 8, we cannot do it by 3 5 or 7. We cannot do it by 11 1 11, so we can do it by 11 now. 11 1 11, so 3 in hand, so 11 3 33, and done. So this you write as 5 into 7 into 11 into 13. So if you multiply all these, 5 into 7 into 11 into 13, pura multiply one after the other, you'll get 5005. That's the whole concept of it. After that, it's done. Got it? Now let's do this, the answer. Like literally, it's that easy. Let's do this. 9 18, so 18 22. We cannot do it with 3. We cannot do by 5. Let's try with 7 7 1. We cannot do by 7 also. Let's try it by 11 9. 13 minus 9. We cannot do by 11 also. So 17. 2 3 7 5 11 but 17 19 to muy tak pen time to opai nai manually grow like. If I try it with 17, 7, I think it would be 4. Yeah, 4s are 68. Okay, subtract 8 9 10 11 12 13 14, so that's 6 remain there. 3 1 2 3 4 51 1 1, and then 9 will come down. So I'm going to try 17 and 7. 9 4 7 1 7 8 9 10 11, so 7. So 17 into 437. Got it? Now let's try by some other numbers. So ekta trick to na itu jani jabo lage. Starting the time the 2 bar pranana wapas 2 na paro to. This one of the tricks that you should know. In the starting you couldn't do by 3, so you won't be able to do it by 3 again. You couldn't do by 5, you won't be able to do it by 5 again. 7 paranai itiwa na paro. 11 also you couldn't do it, I guess. Yeah, so now also you won't be able to do it. So it's either 17 19 or 23 again. So let's try it by 17 again, I guess. 4 3 7. 17 2s are 34. 9 7 7 la timetable 7 ahe nai na, so we cannot do that. So let's try with 19. So 19 2 is 38, 8 9 10 11 12 13, so 5 7, so 19 3 is there, I think. Yeah, 3 is there. Yeah, that's it. So 19 into 23, so we have 17 into 19 into 23 is the prime factorization. Okay, so tips and tricks, easy as it is prime factorization, but you just have to listen to the tips and tricks that I'm giving you. Okay, so let's do this one. Question number 2, you have to find the LCM, HCF, and the most important formula of this chapter is this. Okay, because based on these, questions will come no matter what. LCM into HCF equal to product of two numbers. Okay, so I'm gonna do this in two methods. Okay, so whatever method, don't confuse. So 26, if we prime factorize 2 into 13, nah? So write 2 into 13. 91, if you prime factorize 7 1 0 7 3 0, so 7 into 13, so 8 HCF, highest common factor. Highest common factor means the highest number with which we can divide 26 and 91. That's HCF. Okay, so pratham number 26 and 91 keyword divide into HCF mate. Okay, so the highest number which can divide both 26 and 91 is HCF. And then if it's a big number, this is a small number, so you already know it's going to be 13. But if it's a big number and you have all this list out the prime factors, then the common ones, which is 13 and 13, that's your HCF. Okay, and as for LCM, the lowest common multiple, LCM literally means if you write the tables of 26 and 91, 26 ones are 26, 26 twos are 52, 91 ones are 91, 91 twos are, and so on. What is the first common number that they'll get? That's literally what is LCM. Okay, so like example, timetable, so the shortest way to find out is write the HCF first. Okay, and write everything that's not HCF. So 2 is there and 7 is there, so that's your LCM. So 13 into 14, 4 3s are 12, 2 1 4 4 5 13, so 2 8 1. Now if you do HCF into LCM, okay, so LCM we're getting 182, right? And the HCF is 13. So if you multiply 13 with 8, 3 to the 6, 8 2 3 4 4 2 3 1 3 4 5, and then 2 8 1 6, we're getting 6 13 2. So we're getting HCF into LCM. Product of two numbers of two numbers. So what are two numbers? 91 and 26. So if I multiply 91 and 26, 6 1 6, 9 6 are 54, 2 1 are 2, 9 2 are 18, so 6 6 13 2. So see, here also we got 2 2 6 2 3 6 6. When you multiply the LCM and HCF, when you multiply the two numbers, we're getting 2 3 6 6 also. So the question says verify also, but verification couldn't because this time it's like what? It's just going to be multiple choice. So if it's just going to be multiple choice, verifying the things, it's quite useless, right? We're not going to show it, but the main important thing is the formula. Using this formula, they might give several other questions. Got it? So you have to, like, sometimes they might give you, if LCM is 2, HCF is, no, LCM is 20, HCF is 5. Okay, LCM is 20, HCF is 5, and one of the number is, suppose say 5. What is the other number? You know, they might ask you something like that. Okay, so you can use this formula and do it. So let's do number 3. So first ask you one it 336 just prime factorize 2 1 1 2 6 12 2 8 right. Then you can do, see, it doesn't mean that you have to do it by the smallest number. You can even do it by 3 because you do know that it's divisible by 3, but you cannot do it by 6 directly because it's not a prime number. Got it? In a group order, it doesn't matter as long as you're dividing it by prime numbers. You'll get the same thing on the anyways. 2 8 2 4 2 4 2 2 2 2 2 1 3 7s. So 336 we're getting data 2 1 2 3 4 5 6 and then 54 2 2s 7s 3 3. So 54 is 1 2 and then 1 2 3. So let's see what are the same HCF. These two is same, so we write a 2 into this 3 is same, right? 3. So the HCF is 6. But as for LCM, I think it'll be a little big. We write the HCF first. Okay, you can write 6 directly if you want, doesn't matter, or you can write 2 into 3, doesn't matter, and then write all the remaining. So 2 into 2 into 2 into 7 into 3 into 3, and then you multiply all this. This will be your LCM. So 2 to the 4, 4 to the 8, 8 6 are 48. 48 into 7, 3 to the 9, 7 3 7 9 are 63. 63. So 8 3 4 4 2 8 6 48 4 9 15 5 0 4 2 12 2 1 6 14 14 5 2 5. So 4 2 0 3. So that is your LCM. I'm not gonna verify this because it's kind of useless. Just remember the formula. It's very, very important. And now we're gonna go question number 3. Find the LCM and HCF by prime factorization again. So I'm gonna show you a different method. I mean, like literally you can do the same thing what we did here. Okay, I'm gonna but for 3 numbers. 12, if you prime factorize, you'll get 2 into 2 into 3. 15, you'll get 3 into 5. 21, you'll get 3 into 7. So HCF will be the same one, so which is 3 is there, 3 is there, 3 is there on all. So HCF is 3. LCM is write the 3 into remaining 2 into 2 into 5 into 7. Whenever you have multiplication table of like this now, always remember multiply these two first and then keep it on the side. So 5 2s are 10, 10 side here give you 7 3 are 21, 21 2s are 42, so 420. Got it? That's it. One way to do this 3-digit numbers, even in 2 digits you can do this actually. So first divide by what can the number which can divide all 3. So that is only 3. 3 4 is 12, 3 5 is 15, 3 7 is 21. Now we cannot do by the same number for all 3. So HCF is with whatever you divided. That's your HCF. Okay. That method also we can use. This way easier actually. And LCM is all this multiplied together. Done. That's the easiest way, shortcut method. This is the textbook method. So I'm going to do the shortcut method only. 25. So we cannot divide anything by the same. So HCF is 1. LCM is the product of everything. So 28 4s. 25 4s are 100. So 25 into 8 will be 200. 9 into 200 will be 9 to 0, 18. And by the way, the other formula I wish I showed you, this one, it doesn't work for 3 numbers, okay? It only works for 2 numbers. So suppose, I want to give you an example for this method. Suppose it's 8, 16, and then let's say it's 30. Okay, so first you divide by 2. Now 2 4s are 2 8s are 2 1 5, and you cannot do it anymore now. So wait, let me give you. So HCF will be 2 only. Okay, in this case HCF is 2, but LCM is not the product of all these three, all everything. LCM, after finding the HCF, you have to do it again and again until a number cannot do two things at once. Because right now I know no number can do all three, but at least two can do. See this HCF, dan tadi kotong HCF. So LCM गर्ने to 2 can divide at least this and this also. So you have to do it by 2, and this again we can do. So 15 will just come down. Now there is no numbers which can divide both 2 and 15, 1, 2 or 15. So now you multiply everything. That be your LCM. So don't just do HCF and then multiply everything. LCM though, it has to be like, even if you can divide two things, you have to divide it. Okay, so that's a shortcut for finding LCM. So that's it. Let's do the next question. Question 4, given that HCF equal to 9, LCM, see this is a poorly made question. Okay, it's in the textbook, yeah I know, but tamro ko ase HCF to it was a find the LCM of this and this question. You can literally use the LCM method. 306 5657, and then you do the LCM method. But they actually wanted you to use the other formula, which was this LCM HCF. Okay, so let's just use it. LCM is 306. The product of the two numbers is this, yes, equal to LCM into HCF is 9. Let me just, product of the two numbers equal to LCM into HCF. Nah? So put a 9 this side. But anyway, this is also easier, I guess. It's gonna be a big number, but let's see if we can divide anything by 9. 3 plus 6 is 9, so we can divide by 9. So 9, 3 is 27. 3 in hand, 9 4 is 36. So we just multiply these two, they'll be the LCM. No hassle, na? Here in our layer, time na. 7 4 28, 8 2 5 4 20, 28, 8 2 4 28, 7 4 28, 2 my cube presence and it was 7 4 28, 8 2 5 4 22 1 22, 22 6 4 24, 2 5 26. 6 4 24. I'm not well, that's why. 7 3 3 1 1 2 5 3 15 6 17 7 1 6 3 18 19 1 9 8 3 13 12 2. So that's the LCM. If I'm wrong, let me know. Okay. Anyway, let's go to the next question. Check whether 6 to the power n can end with a digit 0 for any natural number n. So for these kind of questions, what you have to do is, the thing is, anything that has a 2 and a 5 in its prime factorization. I told you 2 or 5 take the last equation multiply, because 2 and 5 multiplied becomes 10, right? So anything that has these two as its prime numbers will always end in 0, no matter what the numbers in front is. Now, whatever the number may be, if it contains this, then it will end in 0. It will be a prime factorization of something which ends in 0. But you have to remember that. For example, I get a quadratic where we got a 0, I suppose. Anyway, that's the whole concept of it. So the question, in this question, we just have to check if it contains 2 into 5 or not. Okay, so prime factors of 6 equal to 2 into 3, nah? So it does not contain 5, right? Since it does not, or since it does not contain, whatever, I'm just writing Mr. okay, because you're not gonna write anyway, contain the prime factors of 2 to the power n into 5 to the power m. Hence, it will not end with the digit 0. Or you can say since it is not of the form 2n to the 5m. Okay. Question. Explain why this and this are composite numbers. Okay. So what are composite numbers? Composite numbers are opposite of prime. Okay. Which are not prime. Prime numbers are which is divisible by 1 and itself only. Composite numbers are which are divisible by anything. Okay. Opposite of prime. Which are not. The numbers which are not prime are composite numbers. So we have to explain without calculation why this is a composite number. It's quite easy. First, okay, we'll just take 13 common here. So if I take, because there's a 13 here, there's 13 here, so if I take 13 common, we'll be left with 7 into 11 plus into 1 plus 1. So 13 and put, correct. So if I open the bracket, 13 into 1, 13, 1 into 13, right? So now this is of the form 13 into something, right? 13 into something. So if I multiply 13 with anything at all, anything, whatever the result is, I will be able to divide it by 13 because 13 into something other, 13 a timetable, was a key, I live, right? Whatever the result, it will be a timetable of 13. So I can divide by 13. Therefore, so it is a composite number. See, I'm going really fast for the exercise questions because you know it's only going to be multiple choice. This one you take 5 common and then the same thing. Okay, like that, and then it's a multiple of 5. So I'm trying to go really fast because they're going to give you only in this thing na multiple choice question. So it's kind of useless, the writing part. That's why I'm just going fast. Okay, last question for today. So, there is a circular path around a sports field. Sonia takes 18 minutes to drive 1 round of the field while Ravi takes 12 minutes for some time. So let's assume there's a sport ground. Okay, and then they both, suppose they both start from the same time at the same spot point. So they start here and Sonia takes 18 minutes to complete one. So that's for Sonia. It takes 1 round, it takes 18 minutes. For 2 rounds, you'll take a total of 18, so 36. 3 rounds, 18 again. So 54 like that. So it goes on. And then there is the other guy, Ravi, who takes 12 minutes for each round. The same spot. So he takes 12. Ravi will 12 minutes, 12 minutes to complete the same one. So he takes 12 on the first round, second 24, next 36, next 48, and so on. So what do you think you should do? They're asking when will they meet again at the same time at the same spot. So it's clearly LCM, right? You have to understand the concept, like if you're supposed to find the HCF or LCM. So since you know that LCM, I've already explained to you, LCM of 6 and 8, suppose, is literally 6 la timetable, 8 la timetable. 6 was 6, 12, 18, 24, 30, and so on. 8 la timetable. It was 8, 16, 24, 32, 40, and so on. And then, if you look closely, the first thing that comes up together is 24. So this is the LCM. So you have to understand the concept of LCM, okay? Lowest common multiplication table, lowest common. So LCM literally means that. So you have whenever the question arises something like this, it can be like traffic lights. There's 2 traffic lights. The green light goes off at this minute, red light goes off. When will the green lights be together or something like that? Like whenever those question comes, when like after some few period of intervals of time, when they're periodically doing something, when will they meet again? That's literally LCM. Got it? And HCF means highest common factor. Highest common factor means the number with which the biggest number with which you can divide something, right? So like what is the highest way you can distribute something, something like that. So any buji jawa like it on LCM HF na example na. So in this question you just find the LCM of 18, and I already drew it here, the multiplication table, and this is the LCM, right? 36. If you don't believe me, you can just do this also. You can do it by 3, 4, 2, 3, 2, 3 to the 6, 6 to the 12, 12 to the 36. So LCM is 36. Okay.